For centuries, binary stars and their unique systems have captivated the minds of astronomers and astrophysicists around the world. It first started with Galileo Galilei in 1617, who thought the second star from the end of the handle on the Big Dipper was of an inconspicuous size. He declared the star was most likely the appearance of two stars too close together to tell the difference. It turned out to be 6. Then nearly 200 years later, Sir William Herschel first gave credence to the term binary stars after charting over 700 pairs of the astronomical objects. Over the last quarter of a millennia, binary star systems have appeared in countless pieces of artwork, literature, and new media. So what about when a system with a binary star reaches the end of its lifespan? What happens when a pair of yellow dwarfs orbit too close to one another and merge into a brilliant, explosive event? Luckily, astronomers of today have the answers mapped out, and according to one predictive model, has the celestial anomaly making an appearance in the night sky in our current year of 2022. Could we truly be in store for exploding binary stars in the near future? In technical terms, a set of binary stars are stars that orbit the same body of mass at their centres. In most scenarios, there is a brighter star, called the primary, and a star of lower luminance, called the secondary star. The bright and dimmer stars are also called stars A and B respectively. If there is no discernible difference between luminosity, the star's designations are determined by the person or persons who found them. There are also two types of binary star groupings, completely dependent on the star's orbits. The first subset is called wide binaries, stars with orbits far from one another that result in binary stars that have not nor will not interact with one another. Their evolutions are separated from one another, and a potential merge is all but impossible. Wide binaries are thought to be caused by ternary star systems, a system with 3 stars, in which the third star pushes the second star away while being ejected from the system itself entirely. Binaries with stars evolving close to one another are considered close binaries. These stars are able to transfer mass from one star to the other through powerful gravitational forces. Forces so strong that sometimes one star will completely absorb the other. That is, of course, if they don't explode into the night first. The final grouping of binary star systems all depends on how they are observed. One such group is called visual binaries, which make up 10% of all binary systems. These are usually wide binaries that can be seen through the lens of a telescope or binoculars, with no further technology needed. Astrometric binaries are stars in the midst of emptier regions in the night sky that appear to be dancing despite not moving. Astrometric binaries are usually close binaries, with the secondary star normally hidden by the primary star's glare. Eclipsing binaries are exactly what their moniker implies. From Earth, the stars' orbits pass one another, making them eclipse when viewed from our home planet. These systems are some of the hardest to spot, as their alignment often tricks astronomers if first viewed in their eclipsing form. Lastly, spectroscopic binaries are close binaries that appear so near to one another that even through a telescope the stars seem to be a single entity. These systems require strict research of their wavelengths for astronomers to study their properties and qualify them as binary, but still account for a major portion of all binary stars in the observable universe. Binary stars are born and evolve much like regular stars. A collection of dust particles and gas caves in on itself and burns strong enough to form a star, albeit into 2 in the case of a binary. There have been instances of binary storms forming after a wandering star travelling through the galaxy passes by another lone star and captures it via gravitational force. However, these scenarios are very rare occurrences. How the stars evolve throughout their lifetimes from here completely depends on the type of binary system they find themselves in. With wide binaries, the evolution of the stars are wholly unrelated to one another, their distance between objects too great to form any sort of symbolic, evolutionary relationship. In the case of close binaries, the stars within will transfer mass back and forth, completely changing the unique makeup of each star. If one of the stars dies, the impending supernova or main sequence layer shred will either destroy the second star or trap it into a separate orbit, slowly swallowing that second star until it does perish. Regardless of how the star evolves, the chemistry and composition of binary stars is what helps astronomers study stars in general all across the galaxy. The push and pull nature of close binaries gives scientists the most accurate readings for mass, temperature, and size, due to active wavelengths on telescope readouts. The evolution of certain binary stars also provides researchers with certain scenarios for finding life away from Earth. Wide binary systems with a host of planets could result in conditions that are optimal for sustaining life, even in the complex variety. In fact, the closest star system to Earth features 3 stars, with 2 binary and a third drifting off in the far side of Alpha Centauri, the name of the system. This system contains a planet that has long been thought to be the closest object we have to Earth that also resembles our planet. One of the planets within the system, called Proxima Centauri b, is a terrestrial exoplanet located in the habitable zone of the star system. 4.2 light-years from Earth, Proxima Centauri b requires further studying before any claims of life can be made, with the heat surges and intense space weather in its vicinity lowering the chances it harbours life in the binary system. Similar reasoning is attributed by most astronomers when discussing the chances of life evolving within other binary star systems, like the close binaries that are most prolific throughout the cosmos. Even close binaries feature habitable zones like their wide counterparts, places where liquid water and other life-cultivating measurements are possible. However, close stars also most likely come with elliptical features, meaning the light is completely blocked out over the planet for long periods of time, leading to ice ages and total freezes that would make sustaining complex life all but a dream. Close binaries also come with double the amount of UV radiation and gamma-ray bursts, in addition to periods of absolutely no darkness when the twin suns are on either side of the planet. It isn't totally impossible to detect life in a binary system. However, you are less likely to find living extraterrestrial organisms than you are to see 2 stars crash into one another and violently explode, which is exactly what was predicted 5 years ago, when one astronomer calculated it would happen this very year of 2022. In early 2017, Professor Lawrence Molnar and his team from the Calvin College in Grand Rapids, Michigan, spoke at the 229th meeting of the American Astronomical Society, also called the AAS. At the conference, Molnar and co. released information that led them to believe the binary star system, titled KIC 9832-227, would merge in 6 years' time, with the impending explosion coming sometime in 2022. The team reported that not only would the binary merger provide astronomers with their first ever real-time study of stars colliding, but would also be visible to the naked eye to anyone who wanted to observe such a celestial event from here on Earth. The work began in 2013 when Professor Molnar recruited students from Calvin College, in addition to interested parties at both the University of Wyoming and the Apache Point Observatory. Together, the group of astronomers and burgeoning minds concluded that KIC 9832-227 was in fact a close binary system, featuring 2 stars with the same atmosphere. This mirrored the data scientists collected for a second binary star system called V1309 Scorpii that merged and exploded in a similar fashion in 2008. The merger and explosion of V1309 Scorpii was unfortunately an unexpected event and wasn't studied in real time. It was the main inspiration for Molnar & Co. to correctly identify KIC as the next opportunity to do so that our understanding of stars could evolve unlike ever before. In terms of witnessing the explosion from Earth, the team of astronomers calculated that the event would be observable in the constellation of Cygnus, and would be just as bright, if not brighter, than what we colloquially refer to as the North Star. Of course, this news fascinated both the scientific community and the general public. How incredible would it be to finally visualize the merging of two stars, and the brilliant effects it would have on the night sky and the understanding of space formation at large. It also led others in the world of astrophysics to question if this was truly possible, or if 2022 was an accurate measurement of time to watch it unfold. Unfortunately, as of today, the once promising potential for a binary explosion in the year 2022 has been all but ruled out. About 2 years after Professor Molnar's initial discovery, in September of 2018, new studies found a timing offset in the original datasets. The prediction had been off by about 12 hours per day over the course of 8 years, and made the collision date of 2022 off by much more. While Molnar & Co. were unaware of the timing issue, their ultimate conclusion isn't necessarily wrong. It just won't be happening this year. All that being said, KIC 9832227 isn't the only binary system set to collide in our lifetimes. V Sagittae, a binary star system in the constellation of Sagitta, is a main sequence star and white dwarf, both of drastically different masses. The white dwarf is slowly but surely absorbing the mass of its main sequence partner, which orbits one another every half day. As the main sequence star accretes onto its white dwarf partner, massive stellar winds are whipped up in the surrounding regions of space. And as these violent events continue, the brightness of the system will exponentially increase. In fact, the luminosity will increase so much that in 2083, V Sagittae will temporarily become the brightest star in our observable night sky, give or take 11 years. At this point, the two stars in the system will fully merge and cause a nova, before finally evolving into a red giant. While it may be disappointing to know the once promised binary event of 2022 is no longer feasible, depending on your age, you still have hope of seeing something of equal magnitude in your lifetime. Maintain a healthy lifestyle, and with a bit of luck, you'll be around to see exploding binary stars light up the night sky in 60 years' time. Thanks for joining us this week in Access Astronomy. We hope to see you here next week, where we will explore more of our vast universe.